Alright, so hopefully you guys had a chance to figure out those last two terms. So here we have plus 3,840 a b to the power of 4 minus 1,024 b to the power of 5. So if you guys haven't noticed, the binomial theorem isn't overly complicated. It's just extremely tedious. You guys are probably going to do one of the questions in your homework, and you guys are probably going to decide that that is enough of that binomial theorem. You're sick of it. Just remember, it could be worse though. Actually doing that all by hand, it's a painful job, and this makes your life so much easier. So as tedious as this question or as the binomial theorem is, it technically saves us a lot of time. All right. And so we can use the binomial theorem to find a specific term in the binomial. Say we had our generalized x plus y to the power of n. So each term in the binomial expansion has the form n choose k times x to the power of n minus k times y to the power of k, where k plus 1 is the term number. So we can find any term in any binomial expansion just by using this wonderful expression or a generalized equation here. So here we have t to the k plus 1. So k plus 1 here is the term number. So to have this exponent k, to find k, it is one less of the term number. Okay, so we'll do an example just to kind of make sure we got see what's going on with this equation here. So just remember, so k plus 1 is the term number. So to find k, you have to subtract 1 from that term number. So in this example here, they want to know what is the third term in the expansion of 5a squared plus 2 to the power of 6. So what I'm going to do is I'm going to first start off, we're going to rewrite out this formula here. So we have t to the k plus 1 is equal to n choose k times it by x to the n minus k times it by y to the k. So now where should we start with this? Should we start plugging in values? Maybe what we should first do is actually figure out what those values are. So to start here, we can say k plus 1. Remember, that is the term number, so k plus 1 is equal to 3. And if we want to solve for k, if we want to find out what that value is, subtract both sides by 1. So we get that k is equal to 2. Our n here, that is equal to our exponent there, so n is equal to 6. And our x value is equal to 5a squared. And our y value is equal to 2. From there we can start putting in some values there. And if we can, if you guys even want to, for n choose k, this one here, if we're thinking about the third term, let's even do it with this. So we have n choose 0. This is our first term. Our second term would be n choose 1. And then the third one would be n choose 2. That is your third term. Okay? So this will help you to know that this k value here should be 2. Alright? So that's just if you guys want to double check. But if not, we can easily find out this information here just by looking at what we're given there and what term number we have. Okay? So t to the k plus, or subscript 3, is equal to n choose k, so that'll be 6 choose 2 times it by x, which was 5a squared, to the n minus k, so it'll be 6 minus 2, times it by y to the power of k, which was squared. That is then equal to, if we're going to change this, you guys may or may not have a combinations and permutations button on your calculator. If you do, you guys hopefully know how to calculate combinations and permutations by now, so you guys can go ahead and do that. If not, let's just solve it out the normal way. So we have 6 factorial over 4 factorial, 2 factorial, and then we have 5a squared to the power of 6 minus 4 times that by, and I guess we should fill in our y. Our y there was 2 squared. Sorry about that. Okay. Then from there we can solve our combination here. So put in 6 factorial, divide that by 4 factorial, 2 factorial, and what we should come up with is 15. Then we can break this apart, so then that'll be multiplied with. We can do 5 to the power of 4 times it by a squared to the power of 4. So you're multiplying those exponents there. So we have a to the power of 8 times it by 2 squared, which is 4. Then multiplying all those numbers together, so we have 15 times 5 to the power of 4 times it by 4. We should get 37,500 times it by a to the power of 8. So that's saying there that our third term in the expansion of 5a squared plus 2 to the power of 6 is 37,508 to the power of 8. Okay? So just use that formula and you can easily calculate the values as long as you know your term number and what the expansion is with that exponent, and then you guys can just solve. Plug it in, solve it. So our last example here before we start our homework is in the expansion of a cubed minus 2 over a all to the power of 7, which term in simplified form contains a to the power of 5? So now where on earth are we going to start with that? So if you guys want to, first what we're going to do is we're going to determine a pattern first. So step number 1 is determine a pattern. And how do you guys think we're going to determine a pattern? So with this one, we're actually going to find the first 3 terms. So find the first 3 terms in your pattern or your binomial, and then look for that pattern. Is A increasing by a certain amount? Is A decreasing by a certain amount? Or is there a pattern at all? We would hope so. That would make our lives a whole lot easier, and this question here magically does have a pattern. It's great. We're going to see what that is. So to do that, we're going to find the first 3 terms. So we're going to be using our binomial theorem, what we know for each term. So here we have a cubed minus 2 over a to the power of 7. So this a cubed here is your x value, here is your y, and 7 here is n. So let's use our binomial theorem. So here we have our first term would be n choose 0. So that would be 7 choose 0 times it by a cubed to the power of n times it by negative 2 over a to the power of 0. That's your first term. So remember, just go back and use that binomial theorem. We know how to find each term. Okay, and then we're going to add. So now we're going to move up one. So it'll be 7 choose 1 times it by a cubed to the power of 6. So remember that exponent decreases by 1. Then we're going to multiply that by negative 2 over a to the power of 1. Then, to find that third term, just to see that pattern, to find that third term, we're going to have 7 choose 2 times it by a cubed, 1 less would be to the power of 5, times it by negative 2 over a, and increase that exponent there, so that is squared. So this here will be our first 3 terms. So let's simplify this and see what kind of pattern we can find, if there's one at all. Alright, so 7 choose 0. This one, as you guys know, is always 1. A cubed to the power of 7, so multiply those exponents together, so we'll have a to the 21, times it by negative 2 over a, to the power of 0 is just 1. So we can multiply it by 1, or we just know that it's just that number itself. Then plus 7 choose 1. If you guys remember what that one is, it's always that value of n. Or if you guys want to see the, I guess it as factorials, we'll do 7 factorial over 7 minus 1 is 6 factorial, 1 factorial. And when we see this n minus 1 in the denominator factorial, that we know for sure is this n value here. Then we'll have that multiplying with a cubed to the power of 6, so multiply those two together. We have a to the power of 18 times it by negative 2 over a. Then what we'll have is 7 choose 2, so that'll be 7 factorial over 5 factorial, 2 factorial, times it by a to the power of, or a cubed to the power of 5. This will be a to the 15. Times it by, that'll be negative 2 over a squared. So that'll be negative 2 squared, which will be 4 over a squared. Then what we can do is we'll simplify this and we'll look at what is going on with that a pattern. If you guys can see that, you guys might see a pattern yet, but what I'm going to recommend is we have these a's in the denominators here that might affect what's going on. So maybe let's first simplify this first. If there was no a in the denominator here, it would be absolutely fine, but because we have the second term with a in it, we need to combine that and see what's going on. So simplifying each of our values there, we have 1 times a to the power of 21 is just a to the 21. 7 factorial divided by 6 factorial. As we know, when it's 1 less, this will be 7. So 7 times negative 2, so we'll subtract 14. A to the power of 18 divided by a, that will decrease that exponent by 1, so we'll have a to the 17. Then we'll have 7 factorial divided by 5 factorial, 2 factorial, times it by 4. If you guys put that into your calculators, we should find that we have plus 84a, and that is a to the power of 15 divided by a squared, so that'll decrease this exponent by 2 to have a to the 13. So now let's look at the pattern. What on earth is going on here? So what is going on with this a value here? So we go from 21 to 17 to 13. So if you guys notice, it's decreasing by a certain pattern, and each time it's decreasing by 4. So the pattern is that we're decreasing by 4. Okay? And so if this one here is the first, this one here is the second, here's the third. So what will the fourth one be? This one will have a to the 13 minus 4. So the fourth term will have 13 minus 4 is 9. Then our fifth term will have a to the power of 9 minus 4. That one there is equal to a to the 5. And that's exactly what we wanted. So we know that the fifth term is going to give us this a to the power of 5. And we don't need to find out what it is. We just want to know what term. So we're going to say that the term that provides a to the power of 5 is the fifth one. And if you guys want to do a check, what we can do is put into our formula from our example that we literally just did. So let's go back up to this formula here. So plug it into there and see if it works. Your k plus 5, this is equal to 1. So it means that your k is equal to 4. That exponent, you guys know, was, we were given that one, so that would be 7. So n is 7. And then plug in your x and y values, and what you should find is that it does equal, and if you guys want to do a check, that whole term there should equal 560 times a to the power of 5. So you'll get this exponent, a to the exponent of 5. So you'll see that it does in fact provide that term. Okay? So if you guys want to, you guys can pause it, try it out, and then you guys can move on to your homework there. And so here is the last video ever. So that is so exciting. So congratulations on making it this far. If you guys have any questions, please let me know.